I'm Besma. I'm a doctoral candidate at Eindhoven University of Technology, part of the High Capacity Optical Transmission Laboratory. So I work on optical fiber communication, more precisely space division multiplexing. So let's talk a little bit about that. In optical fiber communication, there's an ever-growing demand for higher capacity. So we need to find ways to go beyond the currently deployed single-mode fibers, and that's where space division multiplexing comes into play. So we can use the cores or the modes of the fiber to increase the capacity. So we have new fibers like few-mode fiber, multi-core fibers, or a combination of both modes and cores, few-mode multi-core fibers. And these fibers have a great potential for increasing capacity. But for practical implementation in real-world scenarios, we need to understand how these fibers behave, which requires precise characterizations. We can do that for single-mode fibers quite easily because we have instrumentation for that, but there are no off-the-shelf instrumentation for SDM. So in our lab, we use two techniques to do that. So optical vector network analyzer and off-axis digital holography to characterize SDM fibers, components, and subsystems. And that is quite important information to have for both fiber design and to understand the transmission properties, because there are things like mode-dependent loss or crosstalk that severely affect transmission quality. The second part of my research involves transmission experiments to test and demonstrate the suitability of these fibers and pave the way for the next generation high-capacity optical transmission networks.
So let me show you a little bit of our lab. I've mentioned before two characterization techniques. So the first one is the optical vector network analyzer. It's in a rack right here, and we use it to characterize links. So a typical link would consist of a fiber that supports SDM. For example, here we have a few-mode fiber. And then to interface this fiber with the rest of the equipment, we need spatial multiplexers. So we have a multiplexer here, a photonic lantern, which is used to launch light into the fiber, into the different modes here. And then we have a demultiplexer. So with this system, we can measure things like mode-dependent loss, differential group delay, and that gives us important information about our link here. And then if you want to know about, for example, the spatial multiplexer, so on a component level, we would use this setup right here, as you can see on its current work. And we would also get information like MDL and crosstalk. So I also work on transmission. So to do transmission, we would need a transmitter. So here we would generate the signal and then launch it into the fiber. And then we would receive it on the other end. So here we have a SDM TDM receiver. And if we want to emulate long haul communication, we need to recirculate the signal. So for that, we use a recirculating receiver. So to summarize, I work on two main parts in space division multiplexing. So firstly, characterization. And the goal with that is to improve the measurement techniques and then characterize novel components and fibers. And then transmission, and the idea with transmission is to demonstrate the suitability of these fibers for high capacity long haul communication.